to section 2 is slope of a line. We are learning to find the slope of a line from 2 points. We are learning to find the slope from a table. Here are some notes from the textbook. The slope of a line is a ratio, right? Remember, we always want slope to be a fraction. So it's the ratio of the change in y, the rise, to the change in x, the run, between any 2 points. So we use x1, y1, x2, y2 to show those 2 coordinates. So you've learned the slope is the rise over the run, and here is the slope formula on how to find it algebraically with 2 coordinates. A positive slope is a line that from left to right, it goes uphill. A negative line or negative slope, the line falls from left to right. Let's take a look at finding slope from a graph. So I'm going to change my color. Remember, slope is the rise, which means I'm either going up or down, over the run, left or right. So you're going to take the 2 coordinates. In this example, they have given them to us, but if they don't have the points already identified, you could choose any points on the number line or on the coordinate plane. So I'm going to not use their example with their red and blue lines. I'm going to make my own. I'm going to go from this point, -3, -1, and I'm going to rise in the positive direction up. 1, 2, 3, 4, 5. I went up, +5. Now I'm going to run. 1, 2, 3, 4, 5, 6. When I go to the right, that is +6. So my slope is 5/6. In letter B, just by looking at the line, I know that my answer should be a negative fraction. So I'm going to throw a negative over here just to help me remember. Now I'm going to start at this coordinate of -1, 1, and I'm going to rise down. When I go down, that is negative. 1, 2, 3. -3. Now I'm running to the right. 1, 2, which is a +2. So my slope here is -3/2. But let's say I didn't go that way. Let's go the other way. I'm going to go from this coordinate, 1, -2, and I'm going to rise up. Positive. 1, 2, 3. Now I'm going to the left, which is negative. 1, 2, -2. You still get the same slope. It doesn't matter where the negative is. The negative can be in the numerator, the negative can be in the denominator. The fraction as a whole will still be negative. So my slope, or m, equals -3/2. The next 2 examples are for vertical and horizontal lines. Again, it's rise over run. So from the coordinate 4, 2 in the first graph, I'm going to rise up, positive. 1, 2, 3, 4. Rise 4. And do I run left or right? No. So that is a 0. Whenever you have 0 in the denominator, that is undefined. If you did it on the calculator, your calculator would say the word error. You could never, ever, ever, ever have 0 in the denominator. The next example is a horizontal line. So again, let's do our rise over our run. From this point, do I rise up or down to get to this point? No. So that is 0. How many do I run? 1, 2, 3, 4, 5, 6, 7. What is 0 divided by 7? My slope is 0. You could write 0, you could write the word 0. Either way. You just have to pay attention. When 0 is in the numerator, right, that is okay. But when 0 is in the denominator, no, you cannot have that. That is undefined. The last example is finding slope from a table. Remember, a table is just a cute way of writing coordinates, right? And all of these coordinates are solutions to our line. So if you don't like a horizontal table, maybe turn it around, make it a vertical table. You can also just write the coordinates out find slope, you only need 2 coordinates. So you could pick any 2 you want. I'm going to pick this last one, 10, 2. And I'll take the first one, 1, 8. And I'm going to find the slope. So in order to do this, we need to know the slope formula. Oh, let me put my parentheses around here. And let me erase all this so we're not confused. Right. We are going to use the slope formula, which is y1 minus y2 over x1 minus x2, which is in, I think, 2 slides before this. Sometimes we write the change in y over the change in x. It's the difference, the distance between the first y coordinate and the second y coordinate, and the distance between the first x coordinate and the second x coordinate. So I like to stack the coordinates on top of each other and circle the y's, because those are going to go first. So I'm going to subtract 2 minus 8 over, now you're going to subtract your x's, 10 minus 1. Now simplify. 2 minus 8 is negative 6. 10 minus 1 is 9. So our slope is negative 6 ninths. But we know better, and we are also going to create an equivalent fraction, or a simplified slope. I'm going to divide both of these by 3, and my slope is actually negative 2 thirds. And that is it. You could also, if you look at the table here, look at what is the change in y, right? From 8 to 2, if I subtract, that's 2. Or I meant to say 8 to 6 is 2. 6 to 4, it's 2. And 4 to 2, that is also 2. So my y, my change in y, is 2. Now let's look at the change in x. 1 to 4, that difference is negative 3. 4 minus 7, negative 3. 7 minus 10, negative 3. So I get the same answer. Now try some examples on your own.